Okay, so what we're going to do now is we're going to line up the patty paper with one side of the triangle so that the right angle is pointing into the triangle.
So you're doing it like this?
Yep. And I want you to slide down this side this way until this right angle here hits the middle. It hits our middle point, intersection of the angle bisectors. Okay, so we're lined up on the side. Now mark off that distance on this piece of paper.
From here to here?
Yep. Okay, we got a point on here. Okay, now I want you to go try to find that distance somewhere else.
That distance.
Okay.
And that distance there.
Okay, so what does that say about about this point in terms of its distance? What's special about this distance?
It's the same distance away from all three sides.
It's the same distance away from all three sides. So the intersection of the angle bisectors is the same distance from all three sides of the triangle. And the intersection of the perpendicular bisectors was the same distance away from all three vertices. So why is the intersection of the angle bisector the same distance from all three sides? Let's look at that the same way we looked at the other one. Let's look at this angle bisector here. What's special about this line?
Well, it cuts this angle in half, so it's the same distance away from these two sides.
Okay.
So
one question that's a little harder is how do you measure the distance to a side of a triangle?
Well,
like if I'm at this point up here, or even, let's say like I'm just at a random point on this line, to not confuse it with the center point. Let's say we're here on the angle bisector. How do I measure the distance to this side?
I'd say the shortest distance to that side.
Okay.
Just drop, like if you're standing here, you just drop something down onto this side.
Alright.
So go perpendicular.
Alright, so we would say it's about, does that look perpendicular?
Pretty close.
Okay. And what about this side over here? What would I do?
You may have to extend it, you may not. Let's see. But same, you have to drop it straight down like that.
Okay, is that perpendicular?
Yeah, pretty close. Perpendicular. Hit it.
Not sure, that doesn't really look perpendicular to me. But I'll draw it in anyway. Okay.
Little bit.
Close. So are these two distances the same?
They look roughly the same.
Alright, well let's measure them.
Okay. So you can see this one's about 2 inches.
Okay.
That one's about 2 inches.
Lean your head back, please.
That one's about 2 inches.
Okay, so there you go. So the angle bisector stays the same distance away from the lines. And so what's that going to mean about this special distance that we found here?
It's the same distance away from all three sides.
Okay, so that's the property that it has, but what does that mean about that distance? What's going to be special about that distance?
Well, that could be the radius of another circle.
Could be the radius of another circle.
But I also see something else.
Oh yeah? What do you see?
So it looks like these three angles coming from coming from this dot are equal. Like from these here, looks like they're equal.
Which angles are equal? Why don't you show me what angles you mean?
So like this angle, and this angle, and also looks like there's 6 small triangles.
Yeah. Interesting. It won't necessarily be true that those angles are the same. One of the things that's making it look like these are perpendicular, and one of the things making it look like these angles are the same, is the triangle we drew is very close to being an equilateral triangle.
Yeah.
But something is very special about those 6 triangles. You're absolutely right about that. So we'll see that in a second.
Yep.
Okay, so you want to draw the circle? Let's make that our last movement.